So part C says interpret the confidence level. So for that sentence stem is if all possible samples of 340 university, that's not right, university students were selected, 99% of the resulting intervals would contain the true proportion of students who prefer virtual classes. So the sentence stem part of this is if all possible samples of, okay, all that rest is context, and then we say were selected, okay, of the resulting intervals would contain the true proportion of, rest is context.
Would it be better to say randomly selected or no?
You could say randomly selected. It's not going to change the problem because in our original problem above, it already said that it was randomly selected. So we're assuming if they repeat the process, it's also going to be randomly selected. But it wouldn't hurt to put that in there. So again, interpreting the confidence level, when you think back to notes 1, I want you to think of that graph that had all those horizontal lines. Okay, remember each of those horizontal lines meant a different sample that was taken or different simulation that was taken. Out of all of those lines that were on there, 99% are going to have the true proportion of students who prefer virtual classes, which means we could have a couple of them that are red, which means they were outside of that interval, so outside of 0.445 and 0.585, and that 1% is part of the error, okay? It could be that maybe they took their sample wrong, okay? Maybe they added a leading question, okay? Maybe they were like, well, only smart kids like virtual classes. Would you select a virtual class? So on and so forth. We don't know what other biases are in there, and that's what we consider the margin of error. Okay, any questions so far? Okay. No. All gonna get 100 on this test. Okay, now we're looking more at margin of error. So when we talked about our point estimate and standard error yesterday, we had that the statistic, which in our case was p hat, okay, plus or minus the critical value, which was z star, okay, times the standard error, okay, of the statistic, which was p hat, okay. When we were using this type of error, we were talking more about samples. We were not talking too much about confidence intervals, okay. When we're talking about confidence intervals, when we are looking at that, it's always going to be the point estimate, so in our case p hat, plus or minus the margin of error. And remember, in order to find that margin of error, what did we do? Upper bound minus p hat. Okay. How I wrote it in red, okay, without all the extra p hat and z star part, is how you're going to see it on the formula chart, because your statistic and critical value and standard error changes every unit after this. So right now it's z star for critical value. Later it's going to be t star when we start looking at chi-squared distributions. Okay. Recall that this equation in this unit is going to be p hat plus or minus z star times standard error, which is p hat times 1 minus p hat over n. Okay, again, we were dealing with sample size in here. I know that because n is in our formula. Okay, we weren't dealing with confidence level because we don't have a confidence level in the formula. We don't have that percent. Okay. For this next part, again, this would be a great box to highlight, star, happy face, whatever is going to bring your attention back to this, because this box is talking about the relationship between confidence level and other factors, and then sample size and other factors. And this is going to be most commonly used on a multiple choice question. Okay, the question would be like, if the confidence level is increasing, what is happening to the margin of error? And you would have to be able to know those relationships. So for the first one, what's nice about confidence level is that the relationship is direct. What does that mean? If a relationship is direct. Good, as x increases, y increases, which means it's the same. Okay, so I'm going to write that right here, direct relationship. What happens to one happens to the other. Okay. So, for example, if we increase the confidence level, that means that the critical value increases. Okay. That means the margin of error increases, and also the interval increases. In other words, it gets wide. So I'm not saying the interval increases number, it just gets a wider, more broad interval. Okay. So what do you think is going to happen to these three aspects if we're decreasing the confidence level? All decrease, because it's a direct relationship. So the critical value decreases, margin of error decreases, and interval decreases, which means what? Not that the numbers get smaller. It gets skinnier, or it gets more narrow. Okay, so we like confidence level. It's direct relationship, nice and easy to remember. Sample size is going to be the opposite. So instead of a direct relationship, we have a indirect relationship. Okay, which means if one is increasing, then all the other factors have to be decreasing. So for sample size, what you're going to notice first is that we are not using critical value here. Instead, we are using standard error. So if we increase sample size, then standard error decreases, margin of error decreases, and the interval does what? It decreases, so it gets smaller or more narrow. Okay, why are we talking about standard error instead of critical value when talking about sample size? Think of the formula for standard error. In the formula for standard error, is there an n for sample size? Yes, yes, right up here that we wrote, that p hat times 1 minus p hat over n. Yes, most definitely is there an n. Okay, remember sample size is n. Okay, Now, thinking of critical value or confidence level. In order to calculate the critical value, Z star, did we have to know anything about sample size? The N value? No. The only thing we needed to know was what? The confidence level. That's why that critical value is not in sample size and standard error is not in confidence level. They have nothing to do with each other. They have no relationship. Okay, and then continuing on the last one, if decreasing sample size, that means standard error is going to be, oh yeah, you're right, increasing. Okay, I almost wrote the wrong thing. Margin of error is up, increasing, and interval is increasing, which means it gets wide. Okay. So it says, keep in mind the margin of error in a confidence covers only accounts for sampling sampling variability. Sampling variability. The margin of error does not account for bias in sampling methods. So the margin of error is saying, okay, things that we cannot control. It's not talking about every single bias that we learned about. Okay, it's not saying that, okay, did they put a leading question? Did they give false information? Did they do a misleading graph? We're not accounting for any of that when we talk about margin of error. Okay, next part. In this next part, the big thing that I want you to take from this is the formula for margin of error. So let's say we are not given the confidence interval, which means we cannot use upper bound minus p hat. Well, instead, what we could do is use this formula for margin of error, which is equal to Z star times the square root of p hat times 1 minus p hat over n. Or in other words, Z star times standard error. Okay, you will be using this formula on the homework, like almost every question. You're using this formula on the homework. Okay. The other big thing here is if they do not give you a p hat value, you always are going to assume that p hat is 0.5. So if they do not give it to you, we're assuming it's 0.5. Why? Because that's saying a 50-50 chance. Okay, so if they don't give you p hat, or a way to even calculate p hat, right? Because sometimes they could just give you your successes and sample size and say calculate it. But if they don't give you anything, how are you supposed to calculate it? So we're going to say p hat, we're going to be generous and say it's a 50-50 chance by giving it 0.5. Okay, so the last part of the notes, okay, is going to be an example of how all your homework's going to look like tonight. Okay, and the idea behind this is if you have the margin of error formula, depending on different parts that you're given, you are able to find the missing piece. So for example, if you're given margin of error, p hat, and n, you could find what? Z star. And if you know Z star, you can find confidence level. Okay. So that's what we're doing here. So it says, before conducting nationwide polling prior to a national election, most good companies will decide ahead of time how many people to include in the poll based on a particular margin of error and confidence interval. What that means is they want their margin of error and confidence interval to look very, very good in the eyes of other people. So instead of, they're still randomly selecting, but instead of choosing a random number, they're going to make sure they find an exact number that is going to give them a pretty margin of error and a pretty confidence level. So an example of this is, let's say that Gallup wants to conduct a poll to see what proportion of voters would vote for Trump again if Donald Trump was were running for president against Joe Biden. This is obviously old. Gallup wants to be 95% confident with a margin of error no more than 3 percentage points. How many people must they randomly sample in order to achieve this? So in this example, are we given p hat? No, so we have to assume p hat is 0.5 because we're not given it. Okay, so the other thing that we are given is the confidence level, which is 95%. And once we have confidence level using Desmos, we can find Z star, and I just did that for you. It's 1.96. Okay, definitely double check on Desmos later so you understand how to find Z star. Okay. The other information that they give us is the margin of error, and they say they want it no more than 3 percentage points. So 3 percentage points would be 3%. So how would we write 3% as a decimal? 0.03. 0.3 would be 30%. 0.03 is 3%. So now that we have all this information written out, we are going to use the margin of error formula, so that Z star times the standard error. And then we're going to plug in all the information that we were given, which means the only variable that's going to be left over is what? The n, the sample size. And notice, what's the title of the problem? Finding sample size. Finding sample size. Okay, so once we get here, you have 2 choices. You can trust your algebra skills and solve for n, okay? Or I suggest you go ahead and use Desmos, okay? And use the n-solve feature on Desmos. So I'm going to pull that up here. In case you guys don't remember how to use that feature. Remember, the n-solve feature on Desmos means we take our equation and replace our equal sign with what? A squiggly line or a tilde. Okay. And then we do 1.96. I'm just continuing out the problem. Okay, but instead of n, I'm just going to put x sub 1. You can try and see if n sub 1 works. I haven't tried that, but I know x sub 1 does. So when I did this, what number did I end up with? N is equal 1,000. Your guys' favorite number? 67.11. But since we're talking about people, can we have 0.11 of a person? No, so in this case, we always round up. We're going to include that 0.11 of a person and say that they're an actual person. And say that n is actually equal to what? 1,068, and that's our answer.